Hello everyone. Let's continue our analysis of AC circuits, the just basics. So I'm slowly building from fundamentals, from basics. So gradually these videos are going to become more and more complicated, and we'll go all the way up to solving big power system load flow problems also. While we continue in this series of lectures. So let's get started. So here is a question. An EMF is given as V of t is equal to 200 sine 314t plus 30 volts. So here 200 is the maximum value of voltage and the minimum will be minus 200 depending on while the time is changing, the uh, sign will become plus 1 or minus 1, and therefore the voltage will become plus 200 minus 1. You have seen all this already, and 30 degrees is the phase angle. So what do you get from this? So now I'll answer this. So this 314 is omega. Omega is 314, which is also equal to 2 pi into f. And therefore, if you want to know what is f, then simply divide omega by 2 pi. So 314 by 2 pi. So if pi value is 3.14, then you get 50 hertz. So although it is not asked in the question, I'm just as for your information, I'm saying how to calculate the frequency of a given waveform, AC waveform. Now, what about the this value V max? So V max is 200 volts. So, but actually the value which you measure when you connect a voltmeter is the RMS value, and for a sine wave, the VRMS root mean square value is what is usually preferred because that is what we measure. All the time the value will not be 200. So you have another quantity equivalent, so which is V max divided by square root of 2. So that is 200 by square root of 2. So I happen to know that 1 by root 2 is 70.7. So 200 by square root of 2. So let me quickly go to my MATLAB interface and I'll use it as a calculator. So 200 divided by square root of 2, and the value is 141.42. So this I am writing 141.4 volts. So now when you express an EMF in the form of rectangular or polar form, so there are three forms. One is the equation form, and other is the rectangular form, and other is the polar form. So when you express in the form of rectangular and polar forms, you show it as a complex number. So first I will show simple way to write it in the polar form. So polar form, you take the RMS voltage. So that is, so V, I just put as a bar. So that is nothing but 141.4 and angle of 30 degrees. So this is polar form of representation. So typically we show only the RMS value in this rectangular and polar form. We don't show the peak value, that is 200. Okay, so this is polar form. So how to get the rectangular form? So the rectangular form also I denote it with the same, because basically it is the same, just we are the representation we are changing it into rectangular form. It is nothing but 141.4. Now the angle is 30, so it will be sine 30. Sorry, the horizontal component or x-axis component will be cos 30 degrees plus j into sine 30 degrees. So sine of 30 you can calculate, cos of 30 you can calculate, multiply by this, you get the rectangular form. So let's do that. So there is another way to represent in rectangular form, that is nothing but e to the power of j 30 degrees. So if you do this, also equivalently it will come. So mathematically e to the power of j theta is cos theta plus sine theta. So let me write it here. Since e to the power of j theta is nothing but cos theta plus j sine theta. So if I enter this number into the some kind of a calculator, then you can get this. So that is what we are going to do now to calculate this. So let me go back to my calculator interface. So here I will write V equal to 141.4 2 multiplied by exp. So this is the syntax that we use in MATLAB, exp, and then 30 is angle in degrees, but typically this function we have to give the angle in radians. So how do you convert degrees into radians? So divide by 180 degrees and multiplied by pi. Then this will convert the entire 30 degrees into radians, and then also multiply by I. So I is a inbuilt variable. The value of I is square root of minus 1. This is the imaginary number. So hopefully this will give us the value. So let's see. Yes, we are getting V is 122.473 plus 70.71. So let me write that. So I am having 122.47 plus J 70.7. So a little bit about I and J. So I is square root of minus 1. So this is used in maths, whereas in electrical engineering we use J. So J is square root of minus 1. So sometimes we write A plus Bi in maths, whereas this is nothing but A plus JB in electrical engineering. So because for current we use I in electrical engineering, so the I is already taken up by current. So that's about that. And this is the horizontal component, and this is the vertical component. So I think with this we had answered everything in this question. So let's go forward and see more questions. This polar to rectangular conversion, rectangular to polar conversion is very important, and you will be doing all the time as we keep doing this. So let's look at the next question. Four coils are connected in series. Each coil has induced EMF of 100 volts at 50 hertz. But there is a phase difference of 15 degrees between one coil and the next coil, determine the total EMF induced. So if I represent it in the form of a circuit, so four coils are connected in series, and due to some moving magnets or some kind of a machine setup, EMF is induced in this. So how much EMF is induced in the first coil? 100 volts of EMF is induced. How much EMF induced second coil? Again 100 volts. Again third coil also 100 volts. Fourth coil also 100 volts. So the total EMF induced should be 400 volts. But there is a problem. The phase angle is different. So every coil having a phase difference of 15 degrees. So I can either continuously increase or decrease the angle. So if I choose this as my reference, so if this is 0 volts, then this is 15 degrees, then this is 30 degrees, because from here to here it is 15 again, and this is again 45 degrees. So my net voltage, so let's say these are the points. So let's call this as V1, V2, V3, V4. So if I want to get the total voltage from point A to point B, so I'll write V1 plus V2 plus V3 plus V4 is equal to V of AB. So that's what we'll have to do. Now, for addition, rectangular format is suitable. For multiplication, polar format is suitable. So, addition or subtraction. We use rectangular form. And for multiplication or division, we use polar form. However, if you are doing the problem with a calculator. If you are using a computer, for everything you use rectangular form. No need whatever addition, subtraction, multiplication, division, for all you can use rectangular form. So let me define V1, V2, V3, V4 and then add them. So how do I define? So V1 is 100. So this is polar form and this is rectangular form. So V1, V2, V3, V4. So 100 0 degrees, 100 15 degrees, 100 30 degrees, and 100 45 degrees. So by the way, this 100 is the RMS value, not the uh, maximum value. So multiply by root 2, you will get the maximum value. So let's convert this into rectangular form. So how do we convert? I go back to my MATLAB interface. So I'll say clear all. So now I define V1 equal to, so 100 into EXP, exponent, and the angle is 0 degrees. So I don't have to do this, but then for other expressions I required, so I'm just doing this. So 100, and then don't forget to keep I. So 0 into I. So I get V1 equal to 100. The I component is not there. Now I define another variable V2. So then here the angle I increase by 15 degrees. So I'm getting some values like this. Then again I define another variable V3. So that is 30 degrees. So further I'm getting. You notice that the horizontal component is decreasing. 100 is becoming 96, is becoming 86, whereas the y-axis component is increasing. So as the angle increases, this happens. So now at 45 degrees, this is V4. So I have all the four voltages now. So V1, if I want to just display them as a matrix, I can do like this. So these are my voltages V1, V2, V3, V4. I just copy this here and then I'll paste it here. I think let's increase the font. Yeah. So I have all the voltages now. This is in rectangular form. So therefore, what is our next step? To find the total voltage, I have to add them. So I can simply add all these voltages and then I get the solution. So this also I'll go back here and then I simply do V1 plus V2 plus V3 plus V4. So I'm getting 353.91 plus 146.59. So that's what I'll write it here. 353.91 plus J 146.59. So this is in volts. So this is the x-axis component and this is the y-axis component of the voltage. But then exactly what is the value of the voltage? So I can convert this back into polar form. So let me see let me show you how to do that. I'll store this everything into VT, that is total voltage. So now how to get the absolute value? So simply use ABS of VT. So this is the command. Absolute value of VT is 383 volts. So I'll write it as, here I'll write it, V total is equal to 383. Now what about the angle? So for that just type angle of Vt. So since Vt is a complex number, it will calculate the angle. But this angle will be what you see 0.3927, that will be in the radians. So how to convert a radians into degrees? So just multiply by 180 and divide by pi. This will convert radians into degrees. So then you get 22.5 degrees as the angle. So that's what I get here, 22.5 degrees. That's the angle. So that's about this question. 4 coils were given and successively each coil has voltages induced which are displaced by 15 degrees. So as a result we are getting the total voltage to be like this. So let's look at one more problem. An alternating voltage of V equal to 100 sin 376.8 T is applied to a circuit consisting of a coil having resistance and an inductance. So the resistance inductance values are given. What is the instantaneous current flowing in the circuit? So basically instantaneous, whenever you see, that means you have to write it in the form of I of t. So basically the question is, what is I of t? I want to write it as an expression. Okay. And if a voltmeter, wattmeter and a frequency meter are connected in the circuit, what will be their readings? And draw the vector diagram. Let's solve the first one. So the element that is given is a coil. So the coil itself, internally it has a resistance and an inductance. So first thing we find what is the frequency, because inductance we'll have to find out. So the equation given is this one. So omega is 376.8. So the answer is like this. So omega is 376.8, which is nothing but 2 pi f. So this implies f is 376.8 divided by 2 pi. So let's go to the calculator and do that. So 376.8 divided by 2 into pi. So I'm getting 59.97. So I'll approximate it to 60 hertz. So the frequency is 60 hertz. Now, if the frequency is 60 hertz, what is the capacitive? What is the inductive reactance? Inductive reactance is 2 pi f into L, where L is the reactance of the inductance of the coil. So 2 pi into 60 into L. So L given in the question, that is 21.22 millihenries. So milli means 10 to the power of minus 3. So this whole quantity will be my reactive inductance. So let's do that. So 2 into pi into frequency is 60 into L, that is 21.22 E minus 3. So E minus 3 will be 10 to the power of minus 3. So I'm getting 7.9998. So I'll approximate it to 8 ohms. So the impedance is, the reactance is 8 ohms. So because it is an inductive reactance, I can also represent it with a plus J here. So here also it will be J, and then here it will be J8 ohms. So therefore, what is the total? So we have a resistance and a reactance. So this is 6 ohms plus J8 ohms. So my total impedance is 6 plus J8. Now this impedance is in the form of rectangular form. So I convert this into polar form. So again, as I said, many times we are going to do rectangular to polar conversion. So let's go back to the calculator. 6 plus J8 I want to convert into polar form. So absolute value of 6 plus 8i, it is 10, and angle of 6 plus 8. So this I have to convert into degrees. So I do this. So 53.13. So finally I get this value as 10 at an angle of 53.13 degrees. So this is in impedance in ohms. Now what is the voltage? So the given to us V of t is 100 sine 376.8 into t. So this is what is given to us in the question here. So this 100 is actually not the RMS value, this is the maximum value. So therefore V RMS will be V max divided by root 2. So that will be 100 divided by square root of 2. So that will be 70.7 volts. So now I want to express V as a complex number. So this is 70.7, angle will be 0 degrees because phase information is not given. In fact, phase is 0. So now I can find the current. So how to find the current? Simple Ohm's law. So what is the Ohm's law? V equal to I into Z. So for in the case of AC currents, it will be like this. So from this, I can infer that I is nothing but V divided by Z. So that is nothing but 70.7 angle 0 degrees divided by 10 angle 53.13 degrees. So for division, polar form is convenient. And I can easily do this. So divide the magnitudes. So 70.7 divided by 10. So it will be 7.07 amperes of current. And the subtract the angles. So the numerator angle will be positive, denominator angle will be negative. So it will be 0 minus 53.13. So finally it is 7.07 at an angle of minus 53.13 degrees amperes. So this is my current. The magnitude of current is 7.07. That is the RMS value, and then this is the current. Angle of the current, phase angle. And negative sign means that the current is lagging the voltage. And because the voltage is 0 and the current value is less than that, so the current is lagging the voltage, and it's an inductive.
It's 5 o'clock.
Now going back, I think what is the instantaneous current flowing in the circuit was the question. So now to write the instantaneous current, this is IRMS. So IRMS magnitude is 7.07. Therefore, how to get the I maximum? So that is root 2 into IRMS. That is root 2 into 7.07, which will be again 10 amperes as the maximum current. And therefore, once I have the maximum current, I can write small I of t is equal to 10 sine 376.8 t. The frequency will be same. Here it will be minus 53.13 degrees amperes. So this is the instantaneous value of the current. So this is your answer. Let's continue. If I go up, I have the part B of the question. Voltmeter, wattmeter and a frequency meter are connected in the circuit. What will be their readings? So voltmeter reads the RMS value, frequency reads the frequency right away. So we have both of them figured out. So this is a B part. Voltmeter reading is nothing but VRMS. This is nothing but 70.7 volts. Now, wattmeter, we'll come back to it. Frequency meter. Frequency meter reading. So, of course, we also calculated that. So, it will be 60 Hertz. Wattmeter reading. So, wattmeter reads the active power, and the active power can be calculated as VI cos phi. This is one formula. Another formula is I square into R. So let's verify both. So V 70.7 and I is 7.07. All RMS values we have to use. And then cos of angle between them 53.13. So this is one way of calculating. Another way of calculating is I square R. So 7.07 square into 6 ohms is your resistance. So let's see how much we get it. I go back to my calculator. So 70.7 into 7.07 into cos of minus 53.13. But since cos function only takes radians, so I have to convert this degrees into radians. So further divide by 180 and multiply by pi. So that way we do that. So this quantity will be the active power. So I am getting 299.91. So I will approximate to 300 watts. So this will be 300 watts. Let's try this equation also. So 7.07 is the current raised to the power of 2 multiplied by resistance is 6. So again I am getting 299.91, or I can again approximate to 300 watts. So this is about this part of the question. Let's continue. Draw the vector diagram for the circuit. So let's draw the vector diagram. First of all, let's draw the circuit diagram. So the circuit diagram for the circuit is something like this. There is a coil. Although there is a one single coil, I am separately showing the resistance and the reactance. So this whole thing is in ohms. And connected to it is a voltage source where the RMS value of the voltage is 70.7 at an angle of 0 degrees. So the total impedance, as you know, is 10. Therefore, as a result, the current flowing in this can be expressed as 7.07 at an angle of minus 53.13 degrees. And then this total impedance is here. So I show, this is my vector diagram. So I create an x-axis, and this is my voltage magnitude 70.7 volts, and the angle is 0 degrees. Now minus 53 degrees is my current. So I show current below this. So this angle is 53.13 degrees, and this current magnitude is 7.07 and at an angle of minus 53.13. So this is in amperes. So this is the vector diagram for the circuit. We can further write what is the voltage across this, only this resistance. So if you call this as VR and if you call this as VL, I can write what is VR and what is VL. So if I want to write that, so VR is nothing but R into I. So resistance into current. So 6 into 7.07 angle minus 53.13. So this will be how much? Let me quickly calculate. 6 into 7.07. 42.4. So this is 42.4 and the angle is minus 53.13. Now if I want to show this on the graph, so it will be something like this. It will be parallel to the current because the voltage of the current and this will be in phase. So up to here I'll write. So although notice that we are using a different scale for current and voltage. So this is, if this total is 70, this one will be 42.4. Angle is same. So this is VR. Now what is VL? So VL is nothing but XL into I. So what is XL? J8 into 7.07 angle minus 53.13. Now the fact that there is J, that means it is 90 degrees. So J itself represents 90 degrees. So let's do that. 8 into 7.07. So I'm getting 56.56. So this is, but the angle will be 90 minus 53.13. So 90 minus 53.13. So that will be 46.87. So I'll put that vector here like this. So the VL, the length is 56.56 and this angle is, what was the angle? 46.87. So this is 46.87. Now notice that VR plus VL, so these two voltages, if I add, I should get the total voltage. So if you just verify, if I just complete the triangle like this, if you actually draw it according to scale, you will notice that VR plus VL will be V. So VR plus VL will be V. So these are all complex numbers. So in this short video, we tried to solve some problems, just 3 problems on basics of AC circuits. Let's continue and do more problems like this in more videos. Thank you.